expression, it also says that your work is worth more points than the answer itself. Okay? So let's make sure your work looks the way it needs to look. So you're ready. Simplify the expression. 12x squared y plus 6x squared y. What do? Can we combine like terms?
Yes.
I like it. Yes, we can. Why can we combine those terms?
Because they're the same?
Yeah, look at their variables. They're exactly the same. We have x squared y and x squared y. They're exactly the same. So we can combine them. So we do 12 plus 6 and get what? 18. And then what with their variables? Yeah, we keep them exactly the same. For some reason, some people want to like make it x squared or x to the fourth y squared. No, just leave it. Still x squared y. C. Number 2. Simplify the expression. 20xy minus 15x plus 5xy. What are my like terms?
Your xy and xy.
Good job. My 20xy and my plus 5xy. Remember, that plus is part of the term. So then what's going on with my minus 15x? Is that a like term? No, that's a whole different term. So now I combine what I can. I can combine the greens. So what is 20xy plus 5xy?
25xy.
25xy. And what do I do with that minus 15x?
You just put it with the 25xy, so 25xy minus 15x.
Yep, we can't combine it, so it just comes down. So the answer is D. Questions on 1 and 2? All right, number 3. Scott, James, and Dan have $20.25, which is a really odd number for 3 people to have the exact same of. They each spend the same amount, D in dollars, which is also weird, at the school fair. The total amount of money that they still have can be expressed as 3 times the quantity of 20.25 minus D, which expression is equivalent or equal to the total amount of dollars they still have. Are we looking for any mistakes? Is this the type of problem where like we did something wrong? No. So this middle statement right here is the key to the whole thing, because it's telling us a piece of true information. It's saying it can be expressed as that. And what we're looking for is an equivalent or equal to expression. So let's see if we can combine like terms. I'm going to rewrite it just so I have more room to work. 3 times 20.25 minus D. How do I combine like terms here? Because there's nothing I can do inside the grouping symbols. So how do I get rid of them? What can I do? Use the distributive property. Well done. So I have to take that 3 to there and here. For some reason, some of us are forgetting that second term. So what is 3 times 20.25?
60.75?
Yeah, 60.75. And remember, it's the whole term, which includes that negative. So what is 3 times negative D? Yep. Which of those answers most closely matches what we have going on with our answer? D is very, very close, but look, there's something missing in letter D that we need. A is the best answer. They used the commutative property to move this whole term back to the beginning. Any questions on number 3? Number 4. Bonnie purchased cereal in bulk on 2 different trips to the grocery store. She paid $3.27 per pound each time. She purchased 4.7 pounds the first time and 2.5 pounds the second time. Find the expression that can be used to solve the above word problem. So again, I like to do this myself and see if their answers match mine. So if I'm going to the grocery store and I want to find out how much I spent, wouldn't I figure out how much I spent the first time and how much I spent the second time and add them together? Like, isn't that reasonable? So how do I find how much I spent the first time? How much did I spend the first time?
$4.75 times 3.27.
Good. How many pounds I got times how much it was. And we don't need to solve that right this second. How do I figure out how much I spent the second time?
2.5 times 3.27.
And then we would get our answers and add them to get our total, right? Isn't that reasonable? Look at these expressions over on the side. Are there any expressions over there that we can rule out right away because they're not even close to what we did? There's one that I think, two actually, that I think we should look at them and say, they just don't make sense. Why do I think we should rule out D right away? I think D is one that we can look at it and say, nah.
Because, like, where did you get the 2.25 from?
Yeah, I have no idea where that 2.25 came from. Like, I can't find it at all. C a D. The other one that I feel like we can rule out very quickly is the letter B. Why can I rule out the letter B right as well?
Because it's adding all of them.
Yeah, we're just adding everything up. Don't we have to multiply in there somewhere? Okay. C a B. So now I need to make sure that both things are being multiplied by what? 3.27. So which of these is going to make sure everything is being multiplied by 3.27? A. Because again, it's using the distributive property, so that's being multiplied. For C, it's going to use order of operations. So it's going to multiply the first one and then add 2.5. That's why C doesn't make sense. A is the correct answer. Do we all understand where I got the letter A? Like, where does that came from? How did we do on the front? Give me like a thumbs up, thumbs down. Okay. Those of you who are not thumbs up, do you understand what went wrong and how it should look come test day on Friday? Yes? Yes? Okay. All right, let's flip the page. Number 5. The table below shows the relationship between the hours Joe works and how much he's underpaid. At least that's what it should say. How much money does Joe earn if he works 8 hours? Now, a lot of you, I bet, got the right answer, but I want to make sure your work is correct. So, what did you get for your answer?
$50.
$50 is correct. But remember, it says that your work is worth more than the actual answer. So we've got to make sure our work matches. Well, if I want to know how much he earns in 8 hours, shouldn't I figure out how much he makes per hour? How do I do that?
You take the 12 and 50 cents added to. Oh, well, the way you want like the general way or like.
Well, what did you do?
Alright, so I did the 12.50 cents plus the 12.50 cents to make sure I got the exact same hours.
That's the way you could certainly do it. So you could say, well, it goes up $12.50 each time every 2 hours. But my question is, what if the question was, how much does Joe earn if he works 65 hours? You could do it, but it's going to take you a little while, isn't it?
Yeah.
Is there a quicker way? Can we figure out how much he makes every hour?
55, 12, 50 times
Good. So I could say my number of hours worked times how much I get paid per hour will equal the money I earn. And just like he said, if I divide both sides by 2, I know he worked he made $6.25 per hour. All I did was divide the money earned by how many hours he worked. And I find out how much he makes per hour. So now I can just multiply. If he works 8 hours times 6.25, just like, oh, I almost used your name, just like she said, make $50. What about if Joe works 10 hours? I just multiply and get 62.5. If you leave it like this, I will take off a half point. Does anyone know why?
Because you didn't show your work.
Yeah, I did. 10 times 6.25.
But you didn't show your work.
This is all I need for work.
So that the 0?
Yeah, this does not look like money. We don't represent money like this. $62.50. I know it's picky, but we represent money either in whole dollars or to the nearest cent. So I could figure out how much he makes if he works 65 hours. I would just do 65 times 6.25, and I would get my answer. All right, number 6. Number 6 is one where it's easy to get, look at it and say, oh, that's so easy, and then get it wrong because we didn't use our calculator or because we rushed through it. So let's make sure we get this one right. All I'm going to do is rewrite the problem exactly as I see it, and then I'm going to make sure I write these in for what we need. So absolute value, and what does x equal? Negative 24. I am going to keep the operation symbol in the middle. I can't change it. Plus, what does y equal? So now I have the absolute value of negative 24 plus 6. Using your calculator, what is negative 24 plus 6?
Negative 18.
Good. So we have the absolute value of negative 18. I do need to see that step. That is worth a point right there. What is the absolute value of negative 18? 18. The reason I'm so picky about writing it out is what if it looked like this? How would I set up my absolute value? What would my expression look like?
The absolute value is 6 minus negative 24.
That's exactly right. Because that minus has to stay, and x is negative 24. But that's not the problem. I just wanted to make sure you understood we have to write it down exactly the way we see it. All right, last one. Mike purchases some number X of movie tickets for his friend and himself. The cost of each ticket is $10.50. The theater charges a $2.50 fee per order for shipping and handling. Mike uses the discount code to save $5 on his entire order of tickets. Which expression could be used to solve the above problem? Again, let's see if we can do it ourselves first and then find something that matches. So let's just kind of ignore that for now. So how do I figure out how much I spend on tickets? Just in general. What do I do?
1050 times x.
Good. How much the tickets cost times however many tickets I bought. How much did they cost? $10.50. And how many tickets did I buy, or Mike buy? Some number, which is X. Okay, the theater charges a $2.50 fee per order. So that is added to the bill, isn't it? Well, looks like I'm paying another $2.50. Fortunately, he was thrifty and used a discount code to save $5. So what do? Yeah, -5. We're taking that off the bill. That seems reasonable, right? Okay, let's see which one matches. Does A make sense? Why not?
Because they're adding the X.
Yeah, that plus X throws us all off. No dice. Does B make sense? Why not?
Because they're multiplying the 250.
Yeah, they're multiplying the 250. We're not multiplying 250. Does C make sense? At the very least, I can't find anything wrong with it yet, but let's keep going. Does D make sense? Why not?
Because you're multiplying 1050 by everything else.
Good. Or the other way to look at it is, look, we have that -5 times X. Up here, we need the X multiplied by the 1050, don't we? So D does not work because the X is in the wrong spot. C is the correct answer. And it's good because do we really need those grouping symbols? No. They're not wrong, but we don't need them. Because look, all I have to do is grouping symbols. Now it looks exactly the same. All right, if Mike bought 4 tickets, so where do I plug that 4 into? So I have 1050 X plus 250 minus 5. What do I do with that 4?
You put it where the X is.
Yeah, it goes where the X is. So 1050 times 4 plus 250 minus 5. And this is all I need to show for work because I can plug the rest into the calculator. And what will the calculator tell me?
Oh wait, oh.
$39.50.
Good. I love the way you said that because that's what your calculator says, right? Let me move it up just a little bit. Now I added my label because I don't want to lose a half point, but I don't want to lose it because, as he said, I need to make sure that it looks like money. Questions on the second page? So we're looking good on the second page? Perfect. Tomorrow we will do the next couple pages. You do not have to do this for homework.
So we don't have anything?
Calendar project due Friday, and then if you don't finish what you need to with Miss Rico.